This is the walkthrough for the Chapter 3 practice test. If you are in CP, the numbers labeled CP next to some questions will correspond to the question numbers in your packets. Which is the state of matter in which particles are packed closely and locked in place? A. Solids. Particles in liquid are closely packed but not locked in place. Particles in the gas state are neither closely packed nor locked in place, and plasma is not a state of matter that we've discussed. Which is the state of matter in which particles are relatively far apart and have high kinetic energy? C. Gas. Solid and liquid are both closely packed and have relatively low kinetic energy. Gas has high kinetic energy far apart, and again, plasma is not something we've discussed. Which state of matter has a definite volume but indefinite shape? That is liquid. Solids have definite volume and definite shape. Gases have neither definite volume nor definite shape. Which of the following is an extensive physical property? Extensive means it depends on the amount of material you have. So density does not change based on your amount. Mass, if you put more material on the balance, that would change the mass. So that makes that an extensive property. Boiling point doesn't change. Color doesn't change based on the amounts. Which of the following is an intensive physical property? Intensive means it does not change based on the amount of material you have, and you could eliminate length, volume, and mass. Those are all extensive physical properties that do change based on the amount of substance. Freezing point, the freezing point of water is 0 degrees Celsius no matter how much it is. The same would be true for any other material. Which separation technique relies on particles becoming trapped in a porous barrier? Well, that is filtration. Filtration separates liquid from solid particles by letting the liquid pass through. The solids become trapped in the filter, and that's how you separate that type of mixture. Which separation technique separates dissolved substances by forcing them into a solid state? That is A. Crystallization. Distillation relies on boiling point. Filtration we just discussed. Chromatography is based on the fact that certain substances travel through a stationary medium at different rates. Which of the following is a chemical change? Keep in mind, chemical change means the substances are altered in the process. So a piece of wood being chopped in half does not change the composition of the wood, it just makes it into two pieces. An egg cooking. Okay, the proteins and other items in the egg are actually changed during that process. Okay, so that would be B as a chemical. A sheet of steel rolled into cable, you're just changing the shape of the steel, not changing the composition. And stirring the ingredients for a cake together doesn't change their chemical composition. Cooking a cake or baking a cake would change the composition, so that would have been a chemical change. Which fundamental principle states that the mass of the reactants is equal to the mass of the products in a chemical reaction? That is the law of conservation of mass. Okay? Mass is not created or destroyed during a chemical reaction. Which of the following is a physical property of iron? Physical property is something that you can measure without altering the composition of the substance. Reacting with oxygen would change the substance. Melting iron at 1538 degrees Celsius does not change the composition of the iron, it just changes its state. So that would be the physical property here. The symbol is not a property, and combining with sulfur is another chemical property. If a 15-gram sample of magnesium reacts with 10.8 grams of oxide or oxygen, what is the percent of oxygen by mass in this compound? Well, the element is oxygen, 10.8 grams. The total mass of the compound, you have to combine these two numbers, so you get 25.8 times 100. And when you do that out, it comes out to 41.9%. So your answer is C. A substance cannot be broken down into simpler substances by either physical or chemical means is known as an element. Okay, compounds can be separated chemically. Mixtures, either homogeneous or heterogeneous, can be separated physically, but an element cannot be separated into simpler substances by either chemical or physical means. Which of the following is a homogeneous mixture? Sodium is an element, table salt is a compound, brass is an alloy, carbon dioxide is another compound, so the answer here is C. A 24.3 gram sample of sodium azide, which is sodium and nitrogen together, decomposes to release 7.5 grams of nitrogen. How many grams of sodium are also released? This has to do with the law of conservation of mass, which says that the two elements combined must add up to the total mass of the sample. So to find this answer, we take 24.3 grams, which is the total, and subtract the 7.5 grams we know was oxygen, and that comes out to 16.8 grams, which is answer choice B. Identify two physical changes that could be done to an empty aluminum can. Okay, there are many correct answers to this. Examples would be crushing the can, tearing the can, painting the can, heating up the can to melt the aluminum, chopping the can into smaller pieces. If a 59.7 gram candle burns for 4 hours, and after burning it has a mass of 3.9 grams, what is the mass of vapor that's been released into the air? Show your work. Okay, so this is another conservation of mass problem. 59.7 grams is the starting mass. The final mass is 3.9 grams, which means that's the solid that remains. Okay, which means that the vapor is the difference between these two, and that comes out to 55.8 grams. And since both numbers have 1 decimal point, you can leave that decimal point there. This is subtraction, so you keep the fewest number of decimal places. In this question, you're asked to classify 4 different items as either elements, compounds, heterogeneous mixtures, or homogeneous mixtures. So you have to take a look at each one. Sand from the beach. Well, if you take a scoop of sand from one part of the beach and walk to a different part of the beach and scoop another scoop of sand, you might find different substances mixed together in that sand. So sand from the beach would be down here with D, a heterogeneous mixture, because it's not evenly distributed, and you can see the individual components of the mixture, the grains of sand, rocks, shells, things like that. Carbon nanotubes. Carbon nanotubes are made of pure carbon, which is an element that cannot be broken down into anything simpler. There's no other elements involved, it's just carbon, so that would be A. Carbon dioxide gas is carbon and oxygen combined chemically, which makes it a compound. You cannot separate the carbon from the oxygen physically, you could do it chemically. And then stainless steel is an alloy, which is a type of homogeneous mixture. If you slice a piece of stainless steel, despite the fact that it has different components to it, iron, carbon, nickel in some cases, you cannot distinguish the individual parts, but you could separate them by physical processes. It doesn't require chemistry to separate the parts of stainless steel. 2 samples of unknown metal oxides discovered, and there's a typo in this. The second metal here says iron, it should be magnesium, so they're the same in both parts. So the first sample is 38.4 grams with 7.02 grams of magnesium. The second is a 56.1 gram sample with 10.24 grams of magnesium. Are they the same compound? Well, first you want to take the percent by mass of each. In magnesium, the first sample has 7.02 grams of magnesium in 38.4 grams of substance. The second one has 10.24 grams of magnesium in a 56.01 gram sample. So the percentages in the first one comes out to 18.3%. Second one says 18.3% as well. So the question is, are they the same compound? The answer is that we don't know. They could be, okay, but we can't say for sure because we don't know what the other roughly 82% of either compound is. We simply know that they're both 18.3% magnesium. Conversion problem converts 794.2 milliseconds into seconds. So we're going to set up a dimensional analysis here. We've got 794.2 milliseconds over 1. And we're converting milliseconds to seconds, so the conversion 2 goes on top, and 1 millisecond equals 0.001 seconds, so we would multiply 794.2 times 0.001, and that comes out to 0.7942 seconds. If you put that into scientific notation, it would be 7.942 times 10 to the negative first seconds. Perform the following calculation and report your answer with the correct number of significant figures. You're dividing 17.3 by 0.0839, and that comes out to 206.19785.4. Okay, so we need to round here, and we need to look at the total number of significant figures in each number. This is division. They both have 3 significant figures, which means our answer can only have 3 significant figures. So we're going to round that to 206 and drop all of those decimal places.